Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject Network Analysis and Control Systems. I have already uploaded from Module 1 to Module 4 in my channel. Please do watch if you have not watched. In Module 5, I have already completed 2 chapters. In 3rd chapter, today we are going to see one of the topic. In Bode plots, I have already completed basic factors of G of j omega and H of j omega, general procedure for constructing Bode plots, and in this video I am going to cover the computation of gain margin and phase margin. After this I will do a separate video based on the Bode plots. Determination of gain margin and phase margin from Bode plot. This is the given Bode plot. This is the given Bode plot. We should find what gain margin and phase margin. On the Bode plot, gain crossover frequency is defined as frequency at which the resultant magnitude plot crosses the 0 dB line, and phase crossover frequency is defined as the at which the resultant phase plot crosses minus 180 degree line. Here gain crossover frequency is which it crosses what? The 0 dB line, whereas phase margin is which crosses the minus 180 degree line. The difference between the 0 dB line and the resultant magnitude plot as the phase crossover frequency. The resultant magnitude plot at phase crossover frequency. Resultant plot at the phase crossover frequency is what? Is the gain margin. It is the gain margin, the resultant magnitude in dB at the phase crossover frequency. See what the gain margin is, the 0 dB line minus at the phase crossover frequency. If you draw a line, this part, this difference is called what? Gain margin. Gain margin is negative of the magnitude of G of j omega and H of j into H of j omega in dB at phase crossover frequency. If the resultant magnitude plot is below 0 dB line, if the magnitude plot is below 0 dB line and the phase crossover frequency, at the phase crossover frequency, the gain margin is positive and system is stable. See, if this result magnitude plot below the 0 dB line at the phase crossover frequency, if it is at the phase crossover frequency, what happens? It becomes what? The gain margin becomes positive and the system will be stable. If the resultant magnitude plot is above 0 dB, if the resultant magnitude plot is above 0 dB, then the phase crossover frequency, at the phase crossover frequency, the gain margin is what? Negative. The gain margin is what? Negative, and the system will become unstable. See here, the unstable region for intersect on magnitude curve at phase crossover, negative margin you will get. When the you will get negative when the magnitude plot is above the 0 dB line at the phase crossover frequency, and stable region for the intersect on magnitude curve at phase crossover positive gain margin. Okay, if it is this side it is positive, if it is this side it is negative, and stable and unstable. Then what you are with? Then the difference between the resultant phase plot and the minus 180 degree line at the gain crossover frequency gives the phase margin. How you will find the phase margin here? Phase margin, how you calculate is that resultant phase in degrees at the gain crossover frequency, resultant phase in degrees at the gain crossover frequency, minus of minus 180, the resultant phase in degrees at the gain crossover frequency. At the gain crossover frequency, see, this is the gain crossover frequency. This is the degrees at which you will get the gain crossover frequency minus of minus 180 degree. If you do what? You will get the phase margin, that is 5 plus 180 degree. 5 is what? The resultant phase in degrees at the gain crossover frequency. Okay. Then 5 is what? The angle at the gain crossover frequency. Angle at the degrees at the gain crossover frequency. So, if the resultant phase plot is above minus 180 degree, if the resultant phase plot, this is phase plot, no? If this resultant phase plot is above minus 180 degree, if it is above minus 180 degree, then what, the PM is positive and what, the system is what, stable. The system is what, stable. The phase margin will become positive and become stable. If the resultant phase plot is below minus 180 degree, then at the gain crossover frequency, the phase margin is negative and the system is what, unstable. Means if it is below minus 180 degree at the gain crossover frequency, if it is minus 180 degree, below minus 180 degree, then it is what, the system is unstable. So figure 3.1 shows the determination of gain margin and phase margin from the Bode plot. If you see here, in the same way for the gain margin, for the phase margin also, stable region for intersect on the phase curve at gain crossover positive gain margin, and unstable when region for intersect on the phase curve at gain crossover negative phase margin. If it is this side, it is unstable and negative, and if it is this side, it is stable and positive gain margin. Okay. Relative stability related to the slope of the log magnitude curve of the Bode plot. Relative stability related to the slope of the log magnitude curve of the Bode plot. In addition to GM and PM, that is gain margin and phase margin, MR as a relative stability measures the slope of the magnitude curve of the Bode plot of the loop transfer function, and the gain crossover also gives quality indication of the relative stability. It will give what, the quality indication of the relative stability of a closed loop system. In general, the steeper the slope of the magnitude curve, the more negative the phase. If it is steeper the slope, then negative the phase. Thus, if the gain crossover is at a point where the slope of the magnitude curve is steep, it is likely that the phase margin will be small and negative. Okay. Advantages and disadvantages of the Bode plot compared to the Nyquist plot. Nyquist plot we have not yet discussed yet. Just we will see the comparison, how advantages and disadvantages compared to the Nyquist plot. The following are the advantages of Bode plot. That is, an approximate Bode plot can be drawn very quickly. Gain crossover, phase crossover, gain margin and phase margin are more easily determined on Bode plot than the Nyquist plot. When you study Nyquist plot, you can get correct the comparison. But you just remember that gain crossover and phase crossover and gain margin, phase margin easily you can determine in the Bode plot, and is very quick. For design purposes, the effects of adding controllers and their parameters are more easily visualized on the Bode plot than the Nyquist plot. That is, for design purpose, the effects of adding controllers and their parameters are more easily visualized on the Bode plot than the Nyquist plot. Disadvantages. Absolute and relative stability of only non-minimum phase systems can be determined from the Bode plot. The following observations can be made on the system stability with respect to the properties of the Bode plot. That is, the gain margin is positive and system is stable if the magnitude T of j omega at the phase crossover is negative in dB. The gain margin is measured below the 0 dB axis. The same what we have studied. If the gain margin is measured above 0 dB, the gain margin is negative and the system is unstable. What we studied in the graph. The same thing there. Observations they have mentioned once again. The phase margin is positive and the system is stable when T of j omega is greater than minus 180 degree. It is greater than minus 180 degree. At the gain crossover, the phase margin is measured above the minus 180 degree axis. Right? If the phase margin is measured below the minus 180 degree, usually it is measured above the minus 180 degree as it is positive. If it is measured below the minus 180 degree, the phase margin is what? Negative, and the system is what? Unstable. Okay. Gain adjustment in Bode plot. How to do the gain adjustment in Bode plot? In the open loop transfer function g of j omega, h of j omega, the constant k contributes only what? Magnitude. Hence, by changing the value of k, the system gain can be adjusted. Why? Because it is open loop gain. So, it can be adjusted to meet the desired specifications. So, you can change the value of k to change the gain. So, the desired specifications are gain margin GM, phase margin PM, and the phase crossover frequency and the gain crossover frequency. The design specifications you can change is gain margin, phase margin, gain crossover and phase crossover frequency. In a system transfer function, if the value of k is required to be estimated to satisfy a desired specification, then draw the Bode plot of the system with k equals to 1. What they are telling? In a system transfer function, if the value of k is required to be estimated to satisfy a desired specification, if there is a k value and you need to satisfy a desired specification, then we need to draw Bode plot by taking system, by assuming that k equals to 1. You will see that in problems you will get to know the constant k can add 20 log k to every point of magnitude. The constant k can add 20 log k to every point of magnitude plot, and due to this addition, the magnitude plot will shift vertically up or down. The magnitude plot will shift up or down. So, hence shift the magnitude plot vertically up or down to meet the desired specification. We need to shift the magnitude plot either up or down to meet what the desired specification. Equate the vertical distance by which the magnitude plot is shifted to 20 log k and solve for k. See, let x be the change in dB. X is positive if the plot is shifted up and vice versa. When it is negative, when it is shifted down. So 20 log k is equals to what? X. Log k equals to what? X by 20. X is what? The change in the dB, the shift, whatever the shift. So k equals to 10 power x by 20 you will get. So while calculating the phase angles, the following point should be remembered. While for calculating the phase angles, how to calculate? Angle A plus JB equals to what? Tan inverse B by A. My angle A minus JB, it is pi plus tan inverse B by A. If it is like this, then if it is minus A plus JB, it is pi minus tan inverse B by A. And if it is angle A minus JB, then it is minus tan inverse B by A. You should know this so that you can solve the phase angles. These are the points to remember. With this, I stop the topic here. So we are already done with what? Basic factors of G of j omega into h of j omega and general procedure for constructing Bode plots, computation of gain margin and phase margin. We are done with this, and the problems related to Bode plot I will do a separate video. For this, I'll stop the video here. Computation of gain margin and phase margin I discussed in this video. So, thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.